All right, welcome to the very last part of going through your unit for nomenclature test. Formula for dinitrogen tetraoxide, prefixes, so di means 2, tetra is 4, so I'm looking for N2O4, which happens to be letter B. Which of the following does not have covalent bonds? Covalent bonds, again, are nonmetals to nonmetals, okay? So I'm looking for something that does not have that. So basically what I'm looking for is something that has a metal in it, because that would not have the covalent bonds. And so when I look at that, the correct answer is letter C. How many electrons are represented in a covalent bond? When you have covalent bonds, such as F2, this is a molecule, okay? You have one from one fluorine, and you have another electron from another one. So that means the line shares 2 electrons, which is letter A. Okay? Carbon disulfide is polar or nonpolar. So simply we take a look, here's the molecule, and I said I will give you the molecules so that you can figure it out. And simply, if you can cut it in half, okay, and make it kind of look the same, which this one has, this one is nonpolar, okay? Symmetry, okay? If it's nonpolar, it's symmetry. They look the same on both sides. Polar, not the same, okay? Carbon tetrachloride is polar or nonpolar. Here's your carbon tetrahydride, excuse me, okay? Again, take a look at it. If you can cut it in half, yes, you can. It looks the same, nonpolar. Let's see here, dinitrogen, okay, polar or nonpolar. Again, if we cut it in half, okay, this one doesn't look the same. This one is polar, okay. You can't split the two out of this formula, okay. You can't split the 2 electrons, okay. You got to keep those, so you can only go like that, one of those ways. You can't split that paired of electrons. Okay. Now time for some good IMFs. Okay. Again, use the definition to help you. Okay. I take on something that's nice and equal. Okay. We have no wacky symbol. It's nice and non-polar. Okay. And then what happens is we take this molecule with the wacky symbols. This is the dipole. Okay. And we bring it to that nice non-polar molecule. And then what happens is we end up getting those wacky symbols. We get a polar compound. So I am inducing something that should not happen, which is why your correct answer is in fact induced dipole. This one, okay, I've got the wacky symbols for that one, so that means for sure I've got a dipole there. Again, I've got there, so now I have a dipole for sure. So I have to have so for sure it's a dipole, but now I have to figure out whether or not it's a hydrogen bond. And hydrogen bonds occur between HF, HN, and HO, okay? This element here is Cl, and this one is H, so it does not fit that list for hydrogen bond, so we are going to go with dipole with letter B. Okay. This one, there's no symbols, so it's nonpolar, and we have 2 of them, so there's nothing special at all. There's no wacky symbols, there's no dipole, there's no partial positives, partial negatives. This one happens to be London dispersion. Next one, okay, this is sodium with a 1 plus, okay. When you just have a plus or negative, okay, not the ones with the symbols on it, that is the ion, okay. And this one, our water, yes, we have our dipole symbols, so this is a dipole, so I've got an ion and I got a dipole, which means letter A. And last but not least, here we go. I've got a molecule with those symbols. So this is a dipole Same thing goes with this one. This is also a dipole. Now I have to think about whether or not I have a hydrogen bond, okay? And I'm dealing with oxygen and I'm dealing with hydrogen in this case, which in fact is the hydrogen bond, letter C. And that takes care of everything. So hopefully that gives you some more clarification. Obviously, if you need some help or need some clarification on anything, please let me know. And so hopefully this will get you ready for doing your retest.